welcome to linear simultaneous equations, the elimination method. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you'll be able to work along with me as we go through the video. So the first question has to be, what are simultaneous equations? Well, simultaneous equations are a pair of equations with two unknown values. And the solutions to these two unknowns must work for both equations at the same time, simultaneously. That is where the name comes from. They have to happen at the same time. X and Y must work in both equations. So we have a method for this, and if you can follow these 4 steps each time, you're going to reach the correct answer. So the first stage is to scale up the terms of one or both equations to make the coefficients of x or y the same, if necessary. In some cases you won't actually need to do any of the scaling up. The second stage is to use the phrase same sign subtract, add if different. If you use that, it's all about adding, either subtracting the equations from each other or adding the equations together to get a single equation. Stage 3, solve the remaining equation. So we're going to solve that equation. It will only have one unknown variable in there. And then in number 4, substitute the value back in to find the other unknown. I'm going to keep those 4 steps on the screen all the way through this video, just so you can keep track of how we're working through the process. Okay, so let's see if we can put those 4 steps into action. We've got our two simultaneous equations, 3x plus 2y equals 18 and 2x plus 2y equals 14. And so we're going to start with step 1, scale up the terms of one or both equations to make the coefficients of x or y the same if necessary. Well, let's have a look. If we have a look at the coefficients of x, we have 3 and we have 2. They are not the same. But if we have a look at y, we have 2 and 2. And so actually the coefficients of y are already the same. And therefore step 1 is not actually necessary in this case. What we need to do is go straight to step 2, same sign subtract, add if different. Now in this case it's very important that we're only focus on the ones where we have the same coefficient. So we're talking about our y's. And in this case the y's are positive 2 and positive 2. They have the same sign and therefore same sign subtract. We are going to subtract the two equations from each other. And so we're going to take it one step at a time. We're going to have 3x take away 2x, and 3x take away 2x is just x. In terms of the y's, if I have positive 2y and I take away 2y, well, that gets rid of the y's. It eliminates them, and that is why it's known as the elimination method. And so lastly, we have 18 take away 14. Well, 18 take away 14 is 4. And so we have completed step 2. Step 3, solve the remaining equation. Well, in this case, we already know that x equals 4. And so we've already done that. We know the solution to that equation. The final stage is substituting the value back in. So we're going to choose one of the equations, either the top one or the bottom one, to place to substitute x back into. I'm going to choose the top one in this case. So I'm going to take 3 brackets 4 plus 2y equals 18. And so 3 times 4 is 12. So that's 12 plus 2y equals 18. And then if I need to solve this, I'm going to have to subtract 12 on both sides. And so 2y equals 6. And then finally, divide by 2 in both cases. So y equals 3. And so what we've done is we've come up with a solution that x equals 4 and y equals 3. The question is, does it work in both cases? So your 5th step is just an actual check. You can just make sure that it definitely works in both equations. And so you use the other equation and substitute in your values. So in this case, 2 times 4 plus 2 times 3. 2 times 4 is 8, 2 times 3 is 6, 8 plus 6 is 14. That is the answer I was looking for, and so it does work in both equations. We have the right answer. Okay, so in our next question, we're going to go through the same process. So step 1, checking, first of all, have we got the same coefficients of either x or y? Well, if we have a look at this, straight away we can see that there are 4x in both cases. Now here, it doesn't actually matter that one is positive and one is negative. We'll come to that in the next step. But the fact that the number is the same, that there are 4 of them, that is what is important. So step 1 in this case does not need to be performed. Step 2 though tells us to use same sign, subtract, add if different. Well, in this case, the first one doesn't actually have a sign at the moment, but it would be positive. And because they are different signs, that means we need to add. So we're going to add together our two equations. And if we take positive 4x and we add negative 4x, well, they have been eliminated. They are down to 0. So we just need to go then to positive 2y plus 6y. Well, that is 8y. And 18 plus 22 is 40. And so, step 3, solve the remaining equation. Well, that means I need to work out what a single y is, and that would be dividing by 8 on both sides. And so y would equal 5. Step 3 is complete. Step 4, substitute those values back into one of the equations. Well, in this case, I'm going to go with the top one. So 4x plus 2 lots of 5 equals 18. And so if we just work those bits through, so 4x plus 2 times 5 is 10 equals 18. So then I will subtract the 10 on both sides. So 4x equals 8. And finally, I will divide by 4 on both sides. And so x equals 2. So that is telling me that my solution is x equals 2, y equals 5. We just need that last little check though, just to make sure. And so it says negative 4x, so negative 4 times 2, plus 6 lots of 5. Well, negative 4 times 2 is negative 8. 6 times 5 is 30. Negative 8 plus 30 equals 22. And that's exactly what I was looking for. And so I can be guaranteed that we have got our correct solutions. Okay, so we're going to do the same again. Step 1, scale up the terms of one or both equations to make the coefficients of x or y the same if necessary. Well, let's have a look. In this case, I've got 3x and 6x, so they're not the same. And I have 2y and 3y, so they're not the same. So at this point, we actually have to make a decision. How are we going to go about scaling up the equations? And so first of all, I'm just going to label the first equation 1 and the second equation 2. And then we need to make a decision. What is going to be the easiest way for us to get the same number of either x or y? And so what we're looking for here is, can we just multiply one of the equations so that they match? And in this case, if we look at the x's, if I multiply the first equation by 2, then I would get 6x plus 4y equals 22. And what that would mean is that I now have 6x in both cases. And so I'm just going to now remove equation 1 and bring back equation 2. And there we go. And so we have completed step 1. Step 2 then comes down to whether we have the same sign. And so if we have a look at that, well, we are dealing with the x's, and in this case neither of them have a sign, but that would mean that they're both positive, and so we have same sign, subtract. And so I'm going to subtract my two equations. 6x, take away 6x, well, they have been eliminated. 4y, take away 3y, is just y, and 22 take away 18 is 4. So the first thing we know is that y equals 4. We've solved the remaining equation. Then we want to substitute that value back into one of the equations, and we can choose any of the equations. We can choose 1, 2, or the one that we created, number 3. But let's just go with the first one as it's got all of the smaller values in it. So that's 3x plus 2 lots of 4 equals 11. So 3x plus 8 equals 11. So I'm going to have to subtract 8 on both sides. So that is 3x equals 3. And finally, I will need to divide by 3. So x equals 1. And so that is giving me a solution of x equals 1, y equals 4. But as always, we do just want to check that that definitely works. So let's pop it into the second equation. 6 lots of 1 plus 3 lots of 4. Well, 6 lots of 1 is 6. 3 lots of 4 is 12. Add them together, we get 18. And that is exactly what we wanted. So there's our proof. We've got the right answer. And so in this one we want to do the same again. If we look at the x's, we have 3x and we have 4x. If we look at the y's, we have 3y and 9y. Well, it would be easiest if we were to try to make the y's the same, as we can just multiply the first equation. So if I multiply the first equation by 3, I'm going to match up the coefficients. And so let's do that. Let's have 9x take away 9y equals 27. So that is the first equation multiplied by 3. Let's bring back the second equation, which was 4x plus 9y equals -1. And so now we want to just check in terms of the y's. We're on to step 2, same sign, subtract, add if different. Well, we obviously have different signs this time, and so the different signs mean we are going to add those two equations together. If I add them together, 9x plus 4x is 13x. The negative 9y plus 9y, well, they eliminate each other. And 27 plus -1. We've just got to be careful there. That is adding a negative, so it's the same as taking away. So it's 13x equals 26. We want to solve the remaining equation. So in order to do that, we're going to divide by 13 on both sides. And if I divide by 13, well, x would equal 2. And so finally, I want to just substitute that back into one of the equations. And again, it is entirely up to you which equation you use. I would generally go with one that does have all positives in it. So let's use the second equation. So 4 lots of 2 plus 9y equals -1. And so 4 times 2 is 8 plus 9y equals -1. Let's subtract the 8 from both sides. So 9y equals, so that's -1, take away 8, it's -9. And then if I divide by 9, I will get my final answer. Well, that would be y equals -1. And so that is telling me that my solution is x equals 2, y equals -1. Let's just check that that works. We'll use another equation. Let's pop it in the top. So 3 lots of 2 take away 3 lots of -1. Well, that would be 3 times 2, 6. -3 times -1 is +3. 6 plus 3 equals 9. That is what I was looking for. There's my proof that I've got the correct solution. Okay, so then next we have 5x take away 2y equals 11. 2x plus 3y equals 12. In our first stage, we've always been looking to try to match the coefficients of either the x or the y. Now in this case, we don't have a nice quick way of doing this. We can't just look at it and say, well, we'll multiply the top equation or we'll multiply the second. In this case, we're actually going to have to multiply both of them. And so it then comes to deciding which one would we prefer to match. Now, it all comes down to your confidence with your times tables and also confidence with negative numbers. My suggestion would always be to try and think of using the different signs to match, just because that means we're going to be adding at all times, and we're generally all better at adding than we are subtracting, especially when negative numbers come into it. And so what I would like to do is make the y's the same. And how would I do that? Well, if one of them is 2y and one of them is 3y, the easiest way to make them match is to make them both 6y, basically multiplying the two numbers together. So this one, the top one, will still be a negative, the bottom will still be a positive, but the first equation has been multiplied by 3, so everything at the top needs multiplying by 3, giving me 15x, giving me 33 at the end. In the second equation, everything was multiplied by 2, so that gives me 4x at the front and 24 at the end. We've done the first stage. We have matched our coefficients of y, and we are now looking at step 2, same sign, subtract or add if different. Well, we made sure it was an add, so let's do that. So 15x plus 4x is 19x, and the negative 6y plus the 6y have eliminated. 33 plus 24 is 57. So then we need to work out what x must be. So we're going to have to divide by 19. Now, it's not the nicest division to have to do, but if we look at the 19 times table, it'd be 19, 38 and 57, so x would equal 3. So we've completed our step 2 and our step 3. Step 4, substituting that value back in. I'm going to go this time with equation 2, just because all of the numbers are quite small in that one. So 2 brackets 3 plus 3y equals 12. So let's try and solve that. That will be 6 plus 3y equals 12. Let's subtract 6 from both sides. 3y equals 6. And then let's divide by 3. Y would equal 2. So that's telling us x equals 3, y equals 2. And again, all we want to do is just check that that works for the other equation as well. So 5 brackets 3, take away 2 brackets 2. 5 times 3 is 15, 2 times 2 is 4, 15 take away 4 is 11. It's exactly what we were looking for. We have the correct solution. And our last example, we have negative 3x plus 3y equals 15 and 4x take away 5y equals negative 23. In terms of scaling up this time, in this case we have completely free choice as to what we do, especially as if we look at the x's, we have different signs, and if we look at the y's, we have different signs. So actually in this case, no matter which one we match up, we are going to end up with different signs and adding the equations together. So it all comes down to which one we think is actually the easiest multiplications to do. If I'm honest, I would rather multiply by 3 and 4 just because they are smaller numbers. And so in this case, I'm going to make the x's the same value. And the way to do that, well, the first one is going to need to be multiplied by 4 and the second one multiplied by 3. I'm going to make 12x in both cases. And so if I multiply the top one by 4, I get negative 12x plus 12y equals 60. And in the second one, if I'm multiplying by 3, that's 12x take away 15y equals negative 69. And we've said that we had the different signs. So in terms of our x's, they are different signs. So we're going to add the two equations together. So negative 12x plus 12x, they are eliminated. 12y plus negative 15y. We've got to be very careful there. That is adding in negative 15y. So we're actually at negative 3y. And 60 plus negative 69. Again, that is adding a negative number. And so that is negative 9. And so if I need to solve this, well, the first thing I want to do is I want to divide by negative 3. And dividing by negative 3 divided by negative 3 gives me just 1. And negative 9 divided by negative 3, negative divided by negative is positive. And so y equals 3. Let's substitute that back into one of our equations. I'm going to use the second one. So 4x take away 5 brackets 3 equals negative 23. 5 times 3 is 15, so it's 4x take away 15 equals negative 23. So next I want to add 15. So 4x. If I have negative 23 and I add 15, I'm still going to be negative, but it'll be negative 8. And then I need to divide by 4. X equals negative 2. And so my solution is x equals negative 2. Y equals 3, but again, just to be sure, I'm going to check it in the other equation just to be sure. So that's negative 3 brackets negative 2 plus 3 brackets 3. Negative 3 times negative 2 is positive 6 plus 3 times 3, which is 9. 6 plus 9 is 15. That is exactly what I was hoping for. So x equals minus 2 and y equals 3 is the correct answer. And we end today with the exam question. It came from the Edexcel paper in November 2018 and it was on the foundation and higher paper 1. It is a crossover question. It's the sort of a grade 4 to 5 topic. And this is on paper 1, so it's non-calculator, so we have to do this one all in our heads. In this case, we need to solve the simultaneous equations 5x plus y equals 21 and x take away 3y equals 9. Now, in this situation, we'll notice that we don't have a match in x or y to start with. But what we do know is we can multiply one of the equations in order to make that match. Now, again, I would be always looking to see if I can make a positive and a negative match, and so in this case I'd be dealing with the y's. How could I make the same number of y in each case? Well, if I multiply the first equation by 3, I will have 3y in both cases. So let's do that. 15x plus 3y equals 63. The second equation, well, that already has 3y, so I'm going to leave that exactly as it was. X take away 3y equals 9. And because we are dealing with the y's, which have different signs, because they're different signs, I'm going to add. And so I'm going to add together the two equations. 15x plus x would give me 16x. Positive 3y plus negative 3y have eliminated, and 63 plus 9 is 72. So then, how many times does 16 go into 72? We're going to have to do a little bit of a division here. So let's just simplify that fraction down. It's going to be 36 over 8. Let's simplify it a bit further. That's going to be 18 over 4. Going to be 9 over 2. Well, 9 over 2, well, that is 4.5. So we've actually got a decimal this time. X is 4.5. So the process is still the same though. We now need to substitute that value into one of the equations. Let's go with the second one just because the x is a little bit more simple in that case. So x is 4.5. Take away 3y equals 9. So the first thing I want to do, I want to subtract 4.5 from both sides. And so negative 3y equals 4.5. And then I want to divide by 3, or negative 3 actually, divide by negative 3. If I divide by negative 3, that's going to give me y. 4.5 divided by 3, well that is 1.5. And then because it was a positive divided by a negative, it's going to be negative. So that is giving me an answer that x equals 4.5 and y equals negative 1.5. We just need to check that that definitely works. This isn't worth any marks in the exam, but it does make sure that you definitely get the right answer. So 5 lots of 4.5 plus 1 lot of negative 1.5. Well, 5 times 4.5, that is going to be 22.5 plus negative 1.5. Well, plus and a minus is like just taking away, so that is going to be 21. It's what we were expecting, and so the answers x equals 4.5 and y equals negative 1.5 are exactly right.